morning student. Now we are discussing exercise 5.1 class 11th chapter 5 maths NCERT. First 5 questions we have already discussed in previous lecture, and then question number 6. Now we have discussed question number 6, 1 by 5 plus iota 2 by 5, and then minus 4 plus iota 5 by 2. Write in the form of a plus iota b. Is 1 by 5 plus iota 2 by 5 minus 4 minus iota 5 by 2. This and this both are real part. 1 by 5 minus 4 upon 1 and plus this iota, this 2 by 5 minus 5 by 2. Taking LCM, this 5, 1 minus 1 5 the 5, 5 4 the 20, this 20. This is the real part and this imaginary part, and then taking LCM, 5 to the 10, 5 to the 10 and 2 to the 4 minus 2 5 the 10, 5 5 the 25, and then minus 19 by 5 and minus 21 by 10 iota. Is the form of a plus iota b, where a is minus 19 upon 5 and b is minus 21 by 10. And then question number 7. What is the question number 7? And question number 7 is 1 by 3 plus iota 7 upon 3 plus 4 plus iota 1 by 3, and then minus 4 by 3 and plus iota. This 1 by 3 plus 7 by 3 iota, this plus 4 plus iota 1 by 3, and this minus and minus 4 by 3 plus iota. And solve this in the form of a plus iota b. Then 1 by 3 plus iota 7 by 3 plus 4 plus iota 1 by 3. This minus multiply plus हो जाएगी. This plus is 4 by 3 and this minus multiply to plus is minus iota. This and this. 3 terms are real parts. This 1 by 3 plus 4 upon 1 plus 4 by 3 is the real part, and then plus imaginary part is 7 by 3 plus 1 by 3 minus 1. This iota is common. And then 1 by 3, this 4 by 1, this 4 by 3, this 7 by 3, and this 1 by 3, and this minus 1. And taking LCM is 3, then 1 plus 12 plus 4, and plus iota, and taking LCM 3, this 7 plus 1 minus 3, and then 16 17 upon 3, and then 5 by 3 iota plus 5 by 3 iota is the form of a plus iota b. and then next part is 1 minus iota raised to power 4. Now question number 8. Question number 8, 1 minus iota raised to power 4. This term, write in the form of this 1 minus iota and their square and their square. Power की power multiply होती है, then a raised to power m raised to power n, then a raised to power m into n. We know that this, and using this 2 to the 4, then we can write the whole square of a minus b. This a minus b whole square is equal to a square minus 2ab plus b square. And then write in this form, this 1 square minus 2 into 1 into iota and plus iota square and their square. This complete whole square and then their square. This 1 minus 2 iota, and this iota square is minus 1. Iota square is minus 1. You know, this cancel out to this, and then minus 2 iota square, and then minus 2 square and iota square. Minus 2 square is plus 4 and iota square is minus 1, then minus 4, and answer is minus 4. Then next question, question number 9. Question 9. 1 by 3 plus 3 iota and their cube. And we know that a plus b whole cube is equal to a cube plus b cube plus 3a square b plus 3ab square. And we can write this a cube plus b, a cube plus 3a square b plus 3ab square plus b cube. We can write this. And then use this formula in the term 1 by 3 plus 3 iota cube. And then this cube plus 3 into 1 by 3 square, and then 3 iota plus 3 into 1 by 3 and then 3 iota square and plus 3 iota cube. A cube plus b cube plus 3a square b plus 3ab square, and then 1 by 27 plus this 1 3's cancel out to this, and this 1 3's cancel out to this, and only iota. You understand? This 3 into 1 by 3 into 1 by 3 into 3 iota. This cancel out to this cancel out to this, and remain only iota. And then this cancel out to this and this, plus 9 iota square, and then plus 27 iota cube. Iota cube is minus iota. Iota cube is minus iota and iota square is minus 1. Then put the values 1 by 27 plus this iota minus 9 and this plus 27, sorry, minus 27 iota, because iota cube is minus iota. And then this and this are real part. Then 1 by 27 minus 9 upon 1. And then this plus, both term is minus 26 iota. Minus 26 iota. Iota is this. 1 minus 27. Taking LCM, and LCM is 27. This 1 minus 27 into 9. 243 plus, sorry, minus 26 iota, and we can write it this minus 242 upon 27 minus 26 iota is the form of A plus iota B. And then A is minus 242 upon 27 and B is minus 26. And question number 10. Now question number 10. Question number 10 is minus 2. Question number 10. Minus 2 minus 1 by 3 iota cube. Then we can write this minus 1 cube is the common term, and then we can write this 2 plus 1 by 3 iota and their whole cube. Use this formula again, A plus B whole cube, this minus 1, this whole term, minus 1 into minus 1 into minus 1, this minus 1 into minus 1 is plus 1, plus 1 into minus 1 minus 1, and then use this formula A cube plus this 3 into A square B plus 3 A B square plus 1 by 3 iota cube, and then this value is 8 plus this 3 cancel out to this, and then 2 2 ja 4 iota, this 4 iota, and this 1 3 is cancel out to this, and 1 is remain, then 2 by 3 iota, 2 by 3 iota square, 2 by 3 iota square, and then 1 by 27 iota cube, 1 by 27 iota cube. This 3 it will cancel out to this, okay, and then this 8, this 4 iota, this 2 by 3 iota square is minus 1, this 2 by 3 iota, this cancel, sorry, iota 2 by 3 only, and then this and this minus iota, 1 by 27 iota. We can write this. Because iota cube is minus iota and minus iota, this minus is here, and then this and this are real part, then 8 minus 2 by 3 is a real part, and then plus iota, and then imaginary part 4 minus 1 by 27, and then minus 1, this 3, 24 minus 2, plus iota, this 27 is the LCM, this 108 minus 1, and then this 22 by 3 minus this, minus arrange this 22 by 3, and this 107 प्लस ये माइनस, क्योंकि होल टर्म के बाद माइनस का साइन था, एंड देन दिस ब्रैकेट चेंज दिस minus 22 by 3, and then this 107 upon 27 iota, and we can write A is equal to minus 22 by 3 and B is 107 upon 27. Okay, and then question 11, find the multiplicative inverse of each of the complex number given in exercise 11 to 13. Question number 11 to 13, find their multiplicative inverse. And what is the multiplicative inverse? Question 11, 4 minus 3 iota. Find their multiplicative inverse. Like z is a complex number, a plus iota b, and find z inverse. And what is z inverse? Z inverse is 1 by z. We can write this, and this 1 by a plus iota b. And find their conjugate and multiply to numerator and denominator by conjugate. And what is the conjugate? Conjugate z bar से conjugate को लेते हैं, and then they change the sign of complex number in iota form. This real part same रहेगा, चेंज करेंगे साइन को, किसके साइन को? जो आयोटा के साथ है, दैट मीन्स दिस साइन को चेंज करेंगे a minus iota b, and then multiply to this. ये आपका कंजुगेट है, तो कंजुगेट से मल्टीप्लाई करना है. Then let z is equal to 4 minus 3 iota. Then find z inverse. Z inverse, that means multiplicative inverse. 1 by z, that means 1 by 4 minus 3 iota. And then this 1 by 4 minus 3 iota, and multiply their conjugate, and conjugate is 4 plus 3 iota. सिर्फ आपको इमेजिनरी पार्ट का साइन चेंज करना है, रियल पार्ट का साइन चेंज नहीं करना है. This 4 plus 3 iota, and then this 4 plus 3 iota, and then 4 square minus 3 iota square. This a minus b and a plus b using the formula a square minus b square, and then 4 plus 3 iota upon this 16, and this 3 square is 9 and iota square is minus 1, this plus 9, and then 4 upon 25 plus iota 3 upon 25 is the multiplicative inverse of 4 minus 3 iota. Is the multiplicative inverse of 4 minus 3 iota. And next part is what? Question number 12. Then let z is equal to what? The 1 by root 5 plus 3 iota. Root 5 plus 3 iota. And then z inverse is equal to 1 by z is equal to 1 by root 5 plus 3 iota. And then 1 by root 5 plus 3 iota, and then multiply their conjugate to numerator and denominator. Then 3 iota, this root 5 plus 3, minus 3 iota. And then root 5 minus 3 iota upon this root 5 and root 5, this root 5 square, and this a plus b, a minus b, and this 3 iota square, using the formula of identity a plus b, a minus b, then a square minus b square. And then this root 5 minus 3 iota upon this 5, and this 3 3 is 9 iota square minus 1 plus 9. And then root 5 minus 3 iota upon 14. Then we can write root 5 upon 14 minus 3 upon 14 iota. We can write this. And then root 5 upon 14 minus iota 3 upon 14 is the multiplicative inverse of root 5 plus 3 iota. And question 13 is given that 1 minus iota, only given that minus iota, the real part is 0. Then z is equal to 1 minus iota, and sign multiply to this and this value is iota upon iota square is minus 1, this minus, and iota square, this minus plus, and the answer is only iota. And only iota is the multiplicative inverse of question number 13. And question number 14, you can try this question. This multiply of both the term is numerator, and then we also this. Solve question number 14. This question number 14. Write in the form of a plus iota b, 3 plus iota root 5, and this 3 minus iota root 5, this multiply both term, and then root 3 plus root 2 iota, and this minus, and root 3 minus iota root 2, and solve this a plus b, a minus b, using formula this 3 square minus iota root 5 square, and then this root 3 plus root 2 iota minus root 3 plus iota root 2. This cancel out to this, and then this 9, this 5 iota square, this plus 5. Iota square is minus 1, and root 5 square is 5, and this minus 5, and then plus 5, and root 2 iota, and then 14 upon 2 root 2 iota. This cancel out to this 7, and then multiply to their conjugate, then root 2 iota upon root 2 iota. Change the sign of this. And then 7 root 2 iota upon this only 2. Iota square is -1. We can write in the form of this minus 7 root 2 upon 2 iota. We can write this. Okay. Again discuss this. 9 plus 5 is 14 and 2 root 2 iota. This cancel out to this 7 upon root 2 iota. And root 2 iota in denominator, and then is the multiply their conjugate, and conjugate is minus root 2 iota, and minus root 2 iota multiply this minus 7 root 2 iota, and root 2 into root 2, and iota square is -1, and -1 is multiplied to this minus this plus, and is the answer. We can write it this 0 minus 2 root 2 by 2 iota. This is the form of a plus iota b. Thank you.